All right, this video is going to be an introduction to square roots. So, in the past, you have been asked to evaluate things such as 3 squared. Remember that little 2 is called a square, or 3 to the second power. All right, so if I write that out as multiplication, I get 3 times 3. That 2 means multiply my base times itself twice. So 3 times 3, that equals 9. Okay, in this video what we're going to talk about is we're going to talk about going from 9 back to 3. So taking the square root of 9 gives me 3. So do you remember for equations, say we had 2x equals 12, and we want to get x by itself. So we have to do the opposite in order to get the number away from it. So currently 2 is multiplying by x, and we equal 12. So we have to do the opposite of multiplication, which is divide. 2 divided by 2 goes away. 12 divided by 2, we get x equals 6. So we've been doing opposites for a long time now. So we're just doing the opposite of squaring a number. We're taking the square root of the number. Now, the symbol you'll see for that looks like this. So it kind of looks like your long division sign, except it's got this little, I don't know, check mark looking thing on the front of it. This is called a radical. Okay? And it's called a radical because that's the generic term for all the different roots we can take. All right, so we have radicals. Now this is called a square root because technically, not written, but technically, there's a little 2 out here. We're taking the second root or the square root. We always call it square root, not second root. But on the square root, we don't have to write that. But for any other root we do, say we had the cube root, the 4th root, the 5th root, I can take any root of any number. Now I won't always get a nice number, but I can take any root of any number. So it is called the radical. So when people are talking about radicals, you're just going to start dealing with different roots. In this case, we're going to talk about the square root. So that brings me to then square roots. We have what are called perfect squares. So we have these numbers that if we square them, 1 squared, so 1 times 1 is 1. So let's see, 1 times 1, 2 times 2, 3 times 3. So basically what I'm doing is I'm just squaring them to get 1, 4, 9, 16, 25, all the way to 12 squared, which is 144. Now this goes on and on and on and on. We can have 13 squared, 14 squared, 15 squared. We can have all of those. I highly recommend, though, that you memorize the perfect squares 1 through 12. So memorize your 1, 4, 9, 16, 25, 36. Memorize these numbers, because these are going to be the ones that pop up the most often in what we're going to do from here on. So highly recommend that you memorize this table. Now in the videos, this table will be available. Feel free to copy it out of this video and put it on a notes page, whatever you need to do. All right, so we're going to talk about how to go from the blue column to the black column. So let's say I had the square root of 16. I want to know, basically what I'm asking myself here is what number squared equals 16? So I think about it and I think, okay, well, what number times itself equals 16? Well, 4 times itself. So if I do 4 times 4, basically I'm just breaking 16 up into 4 times 4, because if I did 4 times 4, I would get 16, so this is a valid statement. I can rewrite that as the square root of 4 squared, because 4 times 4, 4 times itself, there's 2 4s being multiplied, so it's 4 squared. I can write it with an exponent. Now we said that the opposite of squaring a number is to take the square root. Well, that also means that the square root and a square cancel each other out. And so I'm just left with 4. The square root of 16 is 4, because if I square 4, I get 16. Now what if I had the square root of 121? Well, what number times itself, so 2 numbers in here, times itself equals 121? 11. 11 times 11, or the square root of 11 squared. Square root and a square do what? They cancel. And so I'm just left with 11. Square root of 121 is 11. So the perfect squares, it works out nicely. I'm going to get a nice whole number. Now if I wanted to do like the square root of 13, Well, there isn't a number times itself that equals 13. So in that case, let's go to our calculator. We'd have square root 13. You see that you get a big, long decimal. We get an irrational number. So square root of 13 is 3.60555. Yeah, big number, okay? So you don't get a whole number. So our perfect squares are numbers that when we take the square root of them, we get a nice whole number.